because I feel like that section is a pretty new section for most of you. So let's look at the one on the right. So I'm actually going to erase this one and just focus on the one on the right there. So 1 minus u to the 9th power. All right, so when we talk about a difference or sum of cubes, it's really following a pattern. The pattern for factoring the difference of cubes, so let me write that correctly here, a cubed minus b cubed. And Mr. Middleman talked about this in the video. The pattern looks like this. Whatever the cubed root of this first term is what gets written in here. So if that's 64, then we would write 4. If a cubed was 8, then a would be 2. If a cubed is a cubed, then we just write a. The second thing is whatever the cubed root of this term is gets written here. Again, same kind of process. And then what we do is we take whatever we wrote in that first position. So whatever we wrote here, we then square. We do the same thing with b. And then in between these two terms is just the product of whatever we wrote here. So a times b. Now I want you to notice I haven't written any pluses or minuses in there yet. Okay, this is a pattern, and this works whether it's a cubed minus b cubed or a cubed plus b cubed. Once you have this written, then go in and fill in your signs. So the signs follow a pattern. And the pattern is whatever this sign is in your problem, the first sign is going to be the same as that. The second sign will be different. The third sign will be positive. Always positive. Hi, Mustafa. So same, opposite, or different, always positive. That's our pattern. So when I look at 1 minus u to the 9th power, here's what I know. I know that 1 is a perfect cube because 1 times 1 times 1 will give me 1 cubed. Or sorry, 1 cubed would give me 1. So this is just 1 cubed, okay? Now we have to think about what cubed would give me u to the 9th. And it's really simple to figure that out. Take your exponent and divide it by 3. So u cubed is what we need to cube in order to get u to the 9th. Now we have enough information that we can actually follow our pattern. So I'm going to begin by sort of setting up my formula here. I know in this first position, I'm just going to take whatever the cubed root of this is, which we just said has to be 1. Then I ask myself, what's the cubed root of u cubed? I'm sorry, what's the cubed root of u to the 9th, which we've already written as u cubed, and that's what's going to go here. After that, we take whatever we wrote here and we square it, and that's what goes here. So 1 squared is just 1. We take whatever we wrote here and square it, and that's what goes at the end of that trinomial that we're going to write. So u cubed squared, sounds crazy, is u to the 6th. And then we take whatever we wrote here and multiply it together, and that's what goes in the middle there. So it's going to be 1 times u cubed. At that point, we can fill in our signs, and our signs follow that pattern. So it's same, either you can think of it as different or opposite, always positive. So same, which means it's minus. It's always the opposite, which means that's plus, and then it's always positive here. Now what's really interesting about this one, and this kind of goes in with that mixed multi-step factoring, we aren't done factoring this because hopefully you can recognize that is another difference of cubes. So we'd have to go through that same process for that binomial as well. And just to kind of talk you through that really quickly here, you would have, I'm going to set it up, and then I know at the end I'm going to have this expression that I've already written that cannot be factored anymore, okay? To factor 1 minus u cubed, I know that the cubed root of 1 is 1. I know that the cubed root of u cubed is just u. I'm going to square 1. I'm going to square u, and then I'm going to multiply them together. And then once again, the signs are same as what we started with, which is minus. Opposite, always plus. Now this is factored. It's kind of messy. It's maybe tough on the eyes, but it is factored. Okay, so give me a yes or no. Did that help? Lauren, were you able to get in? Okay, I'm seeing lots of yeses. Good. Okay, good. So the other area that I definitely want to talk about is that mixed multi-step factoring. And the reason I want to talk about that is there. So you may have encountered a problem like this when you were working. And the first thing is being able to recognize that it's actually a difference or sum of cubes. It's a difference because there's a subtraction happening between the two terms. I'm sorry, Matt. Yes, but we have to... Correct. Yes, that's true, Matt. Recognizing that this is a cubed. So you have to understand, first of all, you should know your perfect cubed numbers. I mean, up to probably 7 or 10, like knowing what 7 cubed, 8 cubed, and 9 cubed are is going to be helpful later on. But for sure, up through like 6. And those aren't difficult. You can almost do all of those in your head, but you should definitely know your perfect cubes up to that point. When you recognize that something is a perfect cube, like 1, and you see a subtraction, and then you see it's only 2 terms, that kind of should, again, set off a little alarm bell in your head. That u to the 9th power. The reason we know that that is a perfect cube is because the exponent 9 can be divided by 3. So if it were 1 minus u to the 7th, nothing we can do there. Okay? 1 minus u to the 6th, that we can talk about. And 1 minus u to the 9th, definitely something we should talk about. So let's talk about this. This 1 minus u to the 9th, the pattern for a difference or sum of cubes, and Mr. Middleman talked about this in the video. It was a pretty quick video, but it's really just a pattern that you have to follow. Can it be only 3's when you're talking about the powers in order for it to be a perfect cube? Yes, it has to be divisible by 3. The pattern is whatever the cubed root of this term is A. Okay, that gets written first. Whatever the cubed root of this term is, gets written second. So you end up with this A and B. And I actually want to show you how I work this out. So I'm going to get rid of the rest of this. So I figure out what the cubed root of the first term is, and that's what I write down first. Then I figure out what the cubed root of the second term is. That's what I write down second. So I've actually not even put any signs in here. I'm not worried about them. The next step is to take whatever you wrote here and square it. That goes here. And then you take whatever you wrote here and square it, and that goes at the end of your trinomial. So if that's 2, you would square it, and that's going to be 4 is what you would write. And then in the middle, you're just going to write the product of these two numbers. Okay, so I would write the product of A and B, whatever that is. In this case, it's just AB. If it's an actual number, we write the number. After I've written all of that down, then I go back and fill in my signs. And I think that he talked about the pattern, and I'm not sure, I can't remember or not. The pattern is whatever you see here in the original problem, the pattern is you start with the same sign, then you use the opposite sign, and then it's always plus at the end. So your pattern goes same, opposite, and then always positive. Okay, so I did not worry about putting the signs in as I went because I want to do that at the end. Or you could do it first. It depends on what your preference is. So if I'm going to factor this, I know it's going to be a binomial times a trinomial. Okay, so I know I'm going to have 2 terms to start and then 3 terms to end. Starting with the 2-term piece. In order to fill that in, I have to know what the cubed root of 1 is. In other words, what number times itself 3 times will give you 1. And hopefully you recognize that's just 1. And then we ask ourselves, what number times itself 3 times is going to give you u to the 9th? Okay, so u cubed will give us u to the 9th. And the really easy way to do that, like I said earlier, is just take this and divide it by 3. Whatever that is, divide by 3. That's going to give you the power that goes here. Okay. Now I continue filling in that trinomial, and I say, all right, whatever I wrote here, I square. So 1 squared is just 1. Whatever I wrote here, I square, and I hope you guys know that u cubed squared is going to be u to the 6th. And then again, whatever I wrote here and here, I just multiply together. So that's going to give me 1 times u cubed. You don't have to write the 1 in front of the u cubed there if you don't want to. I am doing it just to illustrate a point. And then we look at following that pattern with the signs. Okay, so the pattern is we're going to take whatever the sign was in the initial problem, which was minus. We're going to do the same as that. Then we'll do the opposite of that. And then we always end with a positive sign. So whatever your difference or sum of cubes is, you want to use this process. Now, remember, always check what you've written to be sure it can't be factored more. First of all, if you've done everything correctly, this trinomial you can't factor. It's just not possible. However, it's important to look at the binomial that you've written because maybe it can still be factored. And I'm hoping you're thinking to yourself, oh, well, that's another difference of cubes. So we would have to go through that same process again. Now I'm going to go a little bit quicker on this one. So I'm going to factor that difference of cubes, but I'm going to write, I'll show you here in just a second what I did here. So I took this guy here and wrote it here. And now I know that I'm going to have to factor another difference of cubes. Okay, so remember that process. I ask myself, what cubed gives me 1? That's going to be 1. Whoops. What cubed gives me u cubed? Remember, divide 3 by 3 and you get just 1. Square that first term, so 1 squared is 1. Square the second term, so u squared is just u squared. Multiply the 2 together, that's just 1u. And then fill in your signs. Same, opposite, always positive. That is the final factored version of that. Now, I know you're probably looking at that thinking, well, that just made it a whole lot more difficult than it would be to just leave it as 1 minus u to the 9th. And you're right, except there may be times that we want to try to simplify a fraction, and it's going to be important that we can do that by factoring that difference of cubes. Matt, if you try it in the quadratic formula, you'll find out very quickly that you're not going to get rational answers. If you're factoring 1 minus u to the 27th. So that's a great question. 27 is 3 cubed, right? So you're only going to be able to get it down 1 step because both terms have to be factorable as a perfect cube. So since 27 is not a perfect cube, or I'm sorry, the difference in sum of cubes. Let me find that, see what I mean. That's a good question. I want to talk about that really quickly. I'm not going to take a whole lot of time on that. So I have one here for you, ready to go. Let me give yourself a little space. If I'm going to factor this, I know that when you use the box, you like that because you know, it's a systematic way to do things, but it takes time. And you might think to yourself, well, so does guess and check. And you're right, it does. But when you get good at it, you won't have to write down every single guess. You're going to start to be able to recognize that's not going to work because the numbers are too big, or that's not going to work because they're not positive. And you'll be able to rule out certain factors pretty quickly. So if I were to actually factor this, I would start by putting 3x and x in the two spots because I know 3x times x is going to give me 3. And then I ask myself, what are the ways that I can multiply two numbers together to get -7? Well, -1 and 7 and +1 and -7 are the only two options there. So then I guess and check. All right. What I know though, and here's where the strategies are going to come into play. I know that my middle term is positive, which means when I start putting in the guesses, I want to try to make sure, because I'm going to have to use a positive number and a negative number, I'm going to have to make sure that my larger product is positive. So right off the bat, I wouldn't want to do this. And the reason for that is I can see right away, actually, I could do that. I lied. I see that my larger number is positive, 7x and -3x. That's fine, except it doesn't add up to 20x, which is what we need. So then I have to ask myself, all right, well, that didn't work. So rather than just throwing that out completely, I'm not going to just eliminate that particular, I don't know why it's made my eraser so small all of a sudden. I'm not going to eliminate -1 and 7, but maybe I try putting them in opposite places. So put +7 here and -1 here, and look at what that does for us, right? So it's going to give us, and now it's a larger eraser again. I don't understand. So that's going to give me 21x minus 1x, and that works, right? That's going to add up to 20x, which is what I needed to add up to. We're going to just approach this as if it is a normal quadratic. And that's really the goal here. Think of it as a quadratic. I kind of titled that video as Quadratics in Disguise because this is really very similar to something that looks like this. So if I gave you what's in the yellow there and asked you to factor it, I'm guessing most of you probably could factor that. Okay, that's a pretty basic trinomial. It's a quadratic. It's a power of 2 is your highest power. For most of you, that does not pose a huge problem. The difference is just in the pattern. So let's just factor the yellow for a minute. Okay, so if we factored the yellow for a minute, going back to our factoring without a box, we set it up so that we know it's going to work. And the first thing we do is we set up the fact that we know that those first two values have to be x's. So once we have that set up, then we think about, okay, what are my values that are going to multiply to be 45? And you just list your possible pairs, right? So I know 1 and 45. I know 3 and 15. 9 and 5. And then I could do all of those with both negatives as well. So I have really 6 possibilities. This is where guessing and checking is going to come into play, but you want to be smart about your guess and check. Okay, so the first thing I'm going to look at is in my trinomial, that middle term is negative, which means that when I add my numbers together, I get a negative number. That's not going to happen when I add two positive things together. So I can eliminate this whole column because if I add two positive things together, I'm going to get positive things. So that leaves me with the second column. So here's my sort of strategy. When I'm factoring, and some of you may already know what this is going to be, and that's fine, but I'm kind of talking through some thought process here more than this particular problem. The strategy here is I always pick the numbers that are closer together to try first. So I wouldn't try 1 and 45 first. I would try 9 and 5. So I'm going to try -9 and -5. And remember, we guess and then check. So when I check this, I'm going to check by looking at the outside terms and the inside terms and seeing if they add up to my middle term. So that's -5x and -9x. And if we add those together, we get -14. So what I know is that that's the way to factor that particular quadratic. Now here's the thing. Our quartic, the only thing that's changing is the fact that instead of getting x squared when I multiply my first two terms together, I need to get x to the fourth. So to get x to the fourth, I need to think about this as being x squared times x squared. Now, some of you may ask, why can't I write x cubed and x to the first? Because that multiplies to be x to the fourth. You would be correct, but here's why. In the next part of this, if I plug in that -5 and -9, when I check my outside and inside terms, I'm not going to get -9x squared and -5x squared, which is what I need in order to get my middle term there. Now there's one more thing to watch, and what we need to be careful with here is that while this is factored correctly, we've done nothing wrong at this point, it's not finished. And the reason it's not finished is because this guy right here, hopefully you recognize that one. Nobody chose difference of squares as an area where they struggled. It is a difference of squares. So what I know is that I can write that as x minus 3 times x plus 3. And then this is a fully factored version of that trinomial. So it might look a little talk about, so and I want to make sure I address that here. So I just wrote one, let's say u minus u, what'd you say? 1 minus u to the 27th. Oh, I see what you're saying. It's not 27. Yeah, you're going to have that. That'll factor a bunch of times. Yeah, you'll get it down to 1 minus u. It's going to be a lot of factors and like 3 or 4 trinomials in there. So that one would be, no, there's not really a quick way to do that one. I mean, it's just multiple steps of factoring. Good. Looking back, there's some questions in there with factoring trinomials with a greater than 1. I'll look at of cubes. If you have something like this. So this is also a quartic, but it's written kind of funny. So I'm just going to rearrange the terms. All right, I'm going to write this as -x to the fourth. I'm going to put that as my first term because it has the highest power, plus 5x squared minus 4. Now, I hate when my leading term, my term that has the highest power, has a negative sign in front of it. So here's what I'm going to do. I'm going to think about this as -1 could be a greatest common factor that I can actually factor out. So I'm going to start with that. If I factor out that greatest common factor of -1, it does something nice for my trinomial. It now makes it x to the fourth, a positive now, minus 5x squared plus 4. And then at that point, you can go ahead and finish factoring that just like you would with the previous problem. So I'm not going to necessarily finish that one. I want you to maybe, if you struggled with that section or need to go back and finish it, try to see if you can, if that helps get you started. Does that help? Give me a yes or no. Does that help with Quartics understand your process a little bit better? I'm seeing a couple yeses here. Okay, good. Lauren, to get on Delta Math, you need to go to deltamath.com. When you log in, go to the Tools menu and Manage Classes. And then you're going to put in my code, which I believe is 201597, and I just put that in the chat for you. Okay, so the other couple that seem to give you some trouble were factoring trinomials with a greater than 1, difference or sum of cubes, and mixed multi-step factoring. Let's go ahead, and there isn't always trinomial. We'll do a level 2. And this would have been something you might have encountered in a level 2 quartic. The problem here, when we first look at this, is it's written kind of in a crazy order. I just said a minute ago I'd like all of my polynomials to be written in descending order. So that means I want to rearrange this. Okay, so I want to rearrange this so we've got our highest power of x first. So the first thing I'm going to do is put negative x to the 4th. Then I see I have a positive 5x squared. That's going to go next. And then I see I have a negative 4. All right. This is great. It's in descending order. But one of the keys when you factor is you'd really like your highest power term to be positive. So the first thing I'm going to do is think about factoring out a negative 1 as a greatest common factor. So before I do anything else, I want to make sure that x to the 4th is positive, which means when I factor out a negative 1 as my greatest common factor, it's going to change all of the signs. Now I've got this trinomial where the highest power is 4, and I have to factor this. And this fits that pattern that was talked about in the video where the second highest power, if we double it, is the highest power. So this is a quadratic. It's just a quadratic in disguise. So what if we thought about this? So what if we actually had that as a quadratic with x squared as its highest power? So what if I had that? Some of you that maybe took Honors Algebra 2 last year, you might remember us talking about doing a U substitution. We're kind of doing that here without actually doing it. We're just looking at a problem that's really similar but not exactly the same to kind of guide our thinking. If I gave you that trinomial, I'm willing to bet most of you could factor that without too many problems. It might take you a minute, but you could do it. The process, remember, is this. I start out by writing the fact that I know both of the first terms have to be x, and then I always just kind of list all of the ways that I can multiply two numbers together to get positive 4. And those ways would be, let's see, 4 and 1, 2 and 2. But don't forget, I can also have negative 4 and negative 1, and negative 2 and negative 2. So there's 4 ways that I can multiply two numbers together to get positive 4. Now, using that process, I'm going to go back up to my original problem. And when I look at this trinomial, I know that the two numbers here have to multiply to be positive 4. But I also know that the middle terms are going to have to add up to a negative 5x. So if I put two positive numbers in these positions, I'm going to get a positive value for the middle term. So right away, I can kind of rule out that it's going to be two positive numbers. So what I do know is it's either negative 4 and negative 1 or negative 2 and negative 2. I'm going to pick one. Let's try negative 4 and negative 1. And remember in the video, we talked about you guess and then you check. So when I check, I'm going to have negative 1x and then minus 4x. If I add these two numbers together, look what I get. I get negative 5, which is what I need. So I know that this is the right way to factor that trinomial. I don't need to try anything else. This is almost identical to what we're actually trying to factor. So the only difference is that instead of writing just x as our first terms in each set of parentheses, I'm going to write x squared. And then the rest of it remains the same. So think about checking this, right? If I multiply x squared times negative 1, I get negative 1x squared. If I multiply negative 4 times x squared, I get negative 4x squared. And when I add those together, I get negative 5x squared. So the reason we use x squared and not x cubed and x to the first is so that our middle terms are going to add up to that squared term that we need. Now this is great, but hopefully some alarm bells are going off for you and you're realizing this is not fully factored, because x squared minus 4 and x squared minus 1 are both differences of squares. So Sam, does it work every time? The what if works. You were in my Algebra 2 class last year, my Honors Algebra 2 class last year. So do you remember U substitution? Really what we did here is I said, let U be x squared. That's what I'm doing there. And then when I rewrite that problem, I'm writing it as x squared minus 5x plus 4 because I'm doing a U substitution. And then at the end, I'm just going back and resubstituting in. So that's why we would have to, so that's all I'm doing. I'm just not going through that substitution process. And if that confused you, please ignore it, okay? That was just a little aside. So what I have is the fact that x squared minus 4 is a difference of squares. I can factor that. And I'm not talking about differences of squares, because it seemed to me like you guys didn't really have a whole lot of issues there. I will say this, though. A lot of people miss that x squared minus 1 is a difference of squares. So that's one that's easy to miss, but it's so easy to factor, so don't miss it. So this would be your final factorization. Okay, so with your quartics, if you had something or some do this. First of all, looking at this, I know that I can't use any of my strategies that we talked about with factoring trinomials because this has 4 terms. So what we're going to do is we're going to think about, is there anything I can do? Is there anything I see here that might be helpful? Caitlin, I'll put that in the chat in just a minute. I'm sorry, I didn't see that from you. I think it's 201597. Sorry, I'm trying to make sure I don't ignore you when you ask a question there. So the one thing that I see we can do is we can actually factor out a greatest common factor. And that just means that there's a factor in every term that we can take out. And that factor that's in every term is z cubed. So I'm going to start by factoring out a z cubed. So what we end up with then is this expression. When you've actually factored out the z cubed, you get an expression with smaller powers. Now that's better, but we have to make sure that this expression, is fully factored. So the next thing, and you're gonna kind of maybe question my my thought process here, but I'm about to use the box to help me factor this. And the reason I do that is because it has 4 terms. With the 3-term polynomial, I don't use the box. It's more work than it's worth. But with this 4-term polynomial, it's actually it's kind of brilliant actually to use the box. If you watched any of the videos on Delta Math for problems like this, it may have shown you an idea of factoring by grouping, and that's fine. If you understood that and were able to follow it, perfect. Otherwise, you can actually use the box to factor this. So if I were to draw my box, which coincidentally has 4 spaces, I can actually put each of these terms in its own space. And that's what I'm going to do here. Okay, so I've got every term in its own space. Now what I'm going to do with that is I'm going to start thinking about, how do I factor this? So I'm going to look for a greatest common factor in each row and column. So if I start out with the first column here, if I'm looking for a greatest common factor here, I'm looking for something that both terms have in common. And the only thing that both z cubed and negative 7z have in common is z. That's it, nothing else. Then I can start kind of really moving forward from there pretty easily. So I can start thinking about the idea that since this is z, this dimension right here is z, well, that leaves me no other option but z squared for the other dimension, because I have to be able to get z cubed when I multiply those two numbers together. Remember, this is based on an area model. So what I've just said is that the length of this side is z and the length of this side is z cubed. So when I multiply length times width for the area of a rectangle, I get z cubed. That's what we're doing here. Now I use that to help me continue. So for the next piece of this, I know that this is z squared. So I ask myself, what's the other dimension have to be so that when I multiply them together, I get negative 6z squared. And that should be pretty quick to figure out. That's just minus 6. And then I can continue that process. Since this length is the same as this length, and they're both z, then I know this length has to be negative 7 in order to factor it. So now I've got my original greatest common factor combined with what I just created by using the box. Now, you can also, so Sam, it kind of does, you want to make sure that you have them in descending order, meaning your powers on Z should go from highest to lowest, and then just put them in that order in the boxes. That'll be the best way to make sure you can actually factor it. If you use the idea of factoring by grouping, then that's fine. If you like that idea, that's great. If not, then you can use this and it might be helpful. For those of you that maybe struggled with that, does that help? Give me a yes or no in the chat. Because I can't see all your screens, so I can see some of you are shaking your head, yeah, it helped, or give me a thumbs up. But unfortunately, I can only see like 8 of you right now. So, okay, good. Awesome. And if we ever go over something and you still have a question, please don't hesitate to say, no, I still have a question, because I want to make sure we're answering your questions before we just move on. All right, so the second topic that was kind of had about half as many responses was factoring quartic trinomials that looked like different x to the 8th. Let's just, I'm not going to give you one that can factor probably because I'm trying to make this off the top of my head. Let's do that. Okay, so let's say you had that. It's really the same thing. Just think of it, because you can tell it's a quadratic, because 4 times 2 is going to give you that 8 that you see as your first power. So think of it as a quadratic. So what I want you to do is just think of it as this polynomial and factor that. And then all you have to do at the end is just go back and instead of writing x squared, or instead of writing x's, you'll write x to the 4th. And it's maybe a way for you to factor that without getting stuck all the time. Does that help? And again, give me a yes or a no in the chat if that helped. See a few yeses here. There weren't as many that asked about that topic, but I did want to make sure we talked about it. And then the one other one, and there weren't very many people that kind of mentioned this one, but I do want to touch on it because it is new probably for you this year, is the idea of a